Welcome to the online lecture series on power electronics. These days we are talking about the different types of filters. In our lecture number 16 and 18, we have discussed about the inductive filtering and capacitive filtering in detail. Today we will be discussing about the rectifier design with LC filter. But before starting LC filter, let us go through the previous lectures, which was capacitive filtering and inductive filtering. So we will discuss about their merits and demerits first, and then we will move towards the design of this LC filter. In capacitive filtering, we saw that the rating of the diodes were very high. Their current was the peak values of the current were up to 78 ampere, and in case of inductive filtering, the ratings of the diode in terms of the current were very low. In capacitive filtering, the transformer rating were very high and the power factor was very poor. And also we saw the effect of increasing capacitance to decrease the ripple in our output, but the drawback associated with the increasing of capacitance was that the peak rating of these diodes kept on increasing as well. And in case of inductive filtering, the ratings of the diodes were very small as compared to capacitive filtering. The transformer rating were less, and we obtained a high power factor of 90%. But there were also some drawbacks associated with inductive filtering. That was the inductance value was very high, 22 Henry, which is quite which will be very difficult to wind, and if the current rating of that inductor is large, in that case it will be the size of the inductor will increase very much. Also, it is expensive and bulky. And we discussed that this type of filtering is not suitable for regulated power supplies. So we are considering the same example that we have used for the inductive filtering and for capacitive filtering. Now we will use the same design considerations and the same design values, so that we can have a comparison at the end in terms of the values of the inductor and capacitance. The output power is 5 kilowatt, output voltage is 1 kilovolt, and the allowed ripple in this output voltage is plus minus 1%. That is, overall delta V is equal to 20 volt, and the average output current is 5 ampere. We will consider this circuit diagram in which we have a transformer source at the input, and the output of this transformer is represented by Vs, and then we have a single phase full wave bridge rectifier, and at its other end we have an LC filter, inductance over here and capacitive filtering over here. So either we were previously we were either using an inductor filter or either capacitor filtering, but now we have combined both of these, inductor and capacitor, to form an LC filter, and here we have a load, and the output voltage is represented by V naught.